Good morning, grade 11s. Just to recap quickly, previously we did the binomial theorem. Now with the binomial theorem, you'll see you've got your a plus b in brackets, and your n, your exponent there, will always be a whole number or a counting number. You'll see if you expand this, it's always an ending series there. It's always the last term, it's ending there. If we want to do this, the question will state, use the theorem and expand, or they say determine the coefficient of x to the power of 4. So there will be a specific term that you must be calculated. So just go through the basics again. The top number of the binomial, it's always the n, and the n will be a whole number. The bottom number of the binomial coefficient starts with a 0. So you start with a 0, and then it's a 1, 2, and then n minus 1n. The first term has always a a to the n. So that one will be a to the n because you take the a and the highest exponent and then you work descending order. The next one will be a n minus 1. Next one will be a n minus 2, and so you carry on. The last term, it's not with a a. Then you take the b to the n. You'll start with no b, it's b to the 0. Then it will be increasing the exponents, b to the 1, b squared, and so you carry on. Right, and if you want to calculate the number of terms, remember n plus 1 terms, that means it will be 3 terms, and n must be a whole number. Now today we want to do the power range. Now the difference between the two, the power range, you'll see, is then formed when the exponent, it's not a whole number, it's a real number. So it can be written as follows. So you will also have your bracket there with the n, but that exponent will be a real number. The second difference then, this one, it's non-ending, it's infinite. So it's non-ending, you don't have a last term there. That n must always be known, and it must always be a 1. There must always be a 1 plus anything for the formula to work. N is a positive integer, right? It can be a real number, and then if n is negative or a fraction, the series will be infinite, so that means non-ending. And the series will converge. Converge means then it's getting closer to a certain value, and the absolute value of x will be less than 1. Okay, so then the series will converge. Now let's have a look at the power range then. If we say expand square root of 1 minus 2x to the term with x cubed. Right, so if you look at that, it will always be like, the question will be expand. Now what must we do with the square root? We will rewrite the square root as bracket 1 minus 2x to a half. Now you can identify, if you look at your rule on top there, it must always be a 1. So now look at the n. The n, it's a real number there. So that means it's the power range. You must start with a 1, so that means then minus 2x. Can you see that 2x is the same as just the x on top? So that second term, there's just the x, but in this case now, it's a 2x. Now this formula will be given to you on the formula sheet. Remember, the n is the exponent. The x is the second term, so that x is the second term. All you have to do is then to substitute. So if I look at this, so according to that, it's a 1 plus nx. So it's a 1, my n is a half, my x will be minus 2x. Put that in brackets. Then it will be n bracket n minus 1 over 2 faculty. So that means my n is a half minus 1, and then 2 faculty. And then I must times it by x squared. remember that second term is now in the place of x, so that's negative 2x squared plus, and then remember you use that now for the substitution, because they say expand to the term with x cubed. Can you see that's my x cubed there? So I must substitute as well my n, half, 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 and then 3 faculty times then my x cubed. Now you're just going to calculate. So that one is still 1. And if you multiply that, a half times negative 2 is the negative 1x. If you multiply that in, right, you get a quarter. Or you can first do the bracket there, it's negative a half, so it's negative a quarter, times then my negative 2x squared, divided by 2 faculty. Remember you can use your calculator. If you look at your calculator, that's your faculty button there. So you can just put it in there. Then you get your answer. So that will be negative half x squared. Then you can use your calculator for that whole term there. Remember that one, negative 2 cubed is then 8, and that's x cubed. If you simplify the whole coefficient there, you get negative a half x cubed. So the question is to expand, and there I've expanded that to the term of x cubed. So this is then the power range. Once again, when will I do the power range? When my n, it's a real number. It's infinite, it's not ending there. And the question will always say expand to a certain number there. The series will converge, that means get to a certain point, certain answer, if the absolute value of x is less than 1. Now remember that x there is my second term. And I must always start with a 1 there. Now, let's do the next question where there's not a 1. So the question now is give the first 4 terms of expansion of 1 over 2 plus x, and give the values of x for which the expansion is valid. So if it's valid, it means converge. Converge means go to a certain point. If you look at this one here, solution, this is then my sum. Remember, I must start with a 1. So to make the 2 a 1, I factorize the 2. So if I take out the 2, I will divide the x by 2. So that forms my bracket there. And now I can say the 1 over 2 makes then a half. In my bracket there, it's in the denominator, so I take it to the top. So it's giving me negative 1. Can you see that's a real number there? A negative integer. So now I'm going to identify. So according to my rule, my n is the exponent, and that will be my x value. According to my rule, you will take out the half, and then you will say 1 plus, and you substitute the values there. So that's my n, and that's my x. That's my n, and that's the x, and that's my faculty. And so I must carry on until 4 terms. So that's term 1, 2, 3, and my 4th term. So where did I get this formula from? So that will be on the formula sheet. That is your power range formula. So you just identify your n and your term there. Must be a 1 there before you can identify that. Now they say the result will be valid. It means converge if your absolute value of x is less than 1. Now in this case, into the place of x is your x over 2. So now you use your absolute values from term 1, and then you can see that your absolute value of x will be less than 2. Let's do the next example. If they say give the first 4 terms of the expansion of that. Once again, can you see that's in the denominator? So I take it to the top. So that means then exponent will be negative 5. But my bracket, my inner function there, must be a 1. What will I do with a 1? With a 32, I factorize the 32. So that means divide there by 32, I get a 1. Divide by 32, that is my expansion. But now you must be careful, because this exponent must also go to the 32. So that's why it's 32 to the power of negative 5. And now I've got my 1, and I've got my x, and I've got my n. So this will stay like 32 to the negative 5. According to my rule, my power range, start with a 1. That's my n, that's my x. Now my x is the second term there. Plus, according to my rule, it will be n times my n minus the 1, it will be x squared times x squared over 2 faculty. And that's the rest you can do there. And then you can just take your calculator and you can simplify. They say 4 terms, so it's 1, 2, 3, 4 terms. The result will be valid for whatever is x. See, now my x is that one there, will be less than 1. Now, absolute value for negative numbers stays positive, and then you just work with your inequalities there, or your absolute values, and then your x will lie between negative 4 square root 2 and plus 4 square root 2.